Hello. Today I will talk to you about ToxiSense for detection of toxic metals in water. ToxiSense is a project by NanoEbers, which is a spin-off company from the American University in Cairo. My name is Hassan Azazi. I'm the CEO of NanoEbers. I'm also a professor and chairman of chemistry department at EUC. Our inspiration for this project is the fact that clean water is a human right. However, clean water may be contaminated with the toxic metal. These include cadmium, lead, and mercury. Cadmium, lead, and mercury actually are listed on the World Health Organization top 10 chemicals of major public health concern, which means they pose extreme dangers to human health. Exposure to lead, cadmium, and mercury will lead to a large number of diseases and damage to different organs in the body, including kidney, liver, brain, lung, and so on. The problem is that continuous exposure to toxic metals will lead to their bioaccumulation in the body, and this will lead to extensive organ and system damage. Water contamination with toxic metal can take place in different types of water. This include drinking or tap water, which may be contaminated with lead due to the use of lead pipes to transfer water to houses. Also, ground and well water may be contaminated due to the presence of the groundwater or the well in a geological area which is rich in one of these toxic metals. Water also may be contaminated due to the discharge of industrial wastewater from certain industries like oil and coal industry and car battery industry into river and sea, which will lead to their contamination with the toxic metals. ToxiSense solution consists of two parts. Number one, novel chemosensor strips. These are the strips, and these actually contain patented technology for sensitive detection of toxic metal, especially lead, mercury, and cadmium in water and wastewater. So these are the strips, each of which will be specific for detection of a specific toxic metal. This will result in a change in the color of the chemosensor. So change of color will indicate the presence of the toxic metal. But if we need to generate a quantitative result, in this case, we have to insert this strip into the device, which is a digital colorimeter device for color analysis. And this will give us a quantitative result on exact level of the toxic metal in water at part per million or part per billion. So essentially, in this area of the strip, we have a nanoporous surface upon which we graft a probe. This probe is specific for a specific toxic metal, could be lead or mercury or cadmium, and then binding of the probe on the surface of the nanosensor with the metal in water will result in a change in the color of the nanosensor. As you can see, the mercury sensor here changed color from yellow to different shades of green. Also, the cadmium sensor changed color from yellow to different colors, including pink, which indicate the presence of the toxic metal in water. The results are instant, selective, and sensitive, low cost, easy to use, and the entire system is portable. We have received a patent. We have been granted a patent from the United States Patent and Trade Office back in January 2019. We also have a large number of publications in peer-reviewed, including the American Chemical Society Sustainable Chemistry and Engineering Journal, Chemical Engineering Journal, Analytical Chemical Acta, as well as Microchemical Journal. These three journals are published by Elsevier. So the ToxiSense solution aims to reduce exposure to toxic metals in water by introduction of sensitive, low-cost detectors of lead, mercury, and cadmium. This will lead to improving human health. It will also support 8 out of the 17 Sustainable Development Goals of the United Nations. These include good health and well-being, clean water and sanitation, as well as reduce inequalities. The ToxiSense kit consists of several components, including the chemosensor strips for detection of cadmium, mercury, and lead. These are the strips. It also contains a plastic syringe to take a sample of the water to be tested. It also has a millipore filter. This is a millipore filter to remove impurities in the water before testing, and a testing container and a buffer solution in order to adjust the pH of the water sample before testing. It also has a color charge to determine the toxicity level, and has an instruction manual as well as handheld digital colorimeter. This project helped to localize new technology and industry in Egypt. It also introduces innovative technology, as we have a patent on this technology that has never been done before in the globe. It fits the global trends as well as the sustainable development goals of the United Nations. It also addresses a huge challenge for everyone in Egypt and globally. Our next steps will include certification of our analysis by participation in external proficiency testing to validate the result generated by the chemosensors as well as the digital device, and expand the testing menu in order to include other chemosensor for detection of additional metals in addition to cadmium, lead, and mercury. We also would like to take our digital colorimeter device to the second level to make it more sensitive. And finally, we like to test toxic metals in cosmetics because actually many people do not know that cosmetics contain a high concentration of toxic metals, and we would like to modify our test to help people to test the presence of toxic metals in their cosmetics. This is the team of ToxiSense. My name is Hassan Azazi. Dr. Ahmed Al-Shahat is a professor of chemistry at Suez Canal University. Dr. Ahmed Al-Suwaifi is a researcher with the company as well as he's a lecturer at Cairo University. Ahmed Radwan is also an assistant lecturer at Ain Shams University. And finally, Ali Magdi, he's an engineer with ToxiSense. And thank you very much.